Imagine standing on the surface of Jupiter, a world so immense that even light itself seems to hesitate. Above you, the sun burns as a distant golden dot, 5 times smaller and dimmer than we see it on Earth. Now picture a single beam of light leaving that sun. In a heartbeat, it blazes past Mercury. In another, it streaks by Venus. And only 8 minutes and 20 seconds later, it finally reaches us on Earth. But what if we could actually trace that journey? What if we could measure exactly how fast light travels across the solar system? How long it takes to touch each planet, from the scorched plains of Mercury to the icy blue edge of Neptune? Welcome to the greatest race in the cosmos, the speed of light across the solar system. Light is the ultimate speed limit of the universe, the fastest traveler known to science. It soars through the vacuum of space at an almost unimaginable velocity, 299,792 kilometers every single second. That's fast enough to circle our entire planet 7 times in just 1 second. Yet, even for something so unstoppable, the distances within our solar system are so vast that light still needs time to cross them. Let's start the race. The starting line is the sun, a roaring ball of plasma over 1 million kilometers wide. Our racer, a single photon, newly born from the sun's surface, now racing into the abyss. In just 3.2 minutes, it reaches Mercury, the swiftest planet, orbiting at breakneck speed close to the sun. After 6 minutes, the beam glides past Venus, where clouds of acid swirl above its molten landscape. 2 minutes later, it strikes Earth, 8 minutes and 20 seconds after its birth, finally warming our blue world. But the journey doesn't end here. Light continues outward into the cold silence. 12 minutes after leaving the sun, it passes Mars, the red wanderer coated in dust and memory. By the 43-minute mark, it's sweeping past Jupiter, the mighty king of planets, so large it could fit 1,000 Earths inside. After 1 hour and 20 minutes, the light crosses Saturn's magnificent rings, where icy particles shimmer in its glow. 2 hours and 40 minutes later, it touches Uranus, tilted and distant, its pale green hue glowing faintly in the void. And finally, after 4 hours and 15 minutes, that same ray of light reaches Neptune, the blue sentinel guarding the solar system's outer frontier. 4 hours. That's the difference between sunrise on Earth and sunrise at Neptune. Beyond even that, sunlight still travels further, to the realm of Voyager 1. The lonely spacecraft now drifting through interstellar space. Sunlight takes nearly 22 hours to reach it. Imagine, the warmth you feel every morning left the sun 8 minutes ago, but Voyager's light won't arrive until almost a full day later. Now picture yourself riding that beam of light. Every planet blurs beneath you like glowing marbles suspended in darkness. You'd watch orbits curve around the sun like ribbons of silver. Planets crawling slowly in their endless dance while you shoot through space at impossible speed. Earth would fade behind you into a tiny blue spark. Jupiter's stripes and Saturn's rings would flash past in moments. Even traveling at the speed of light, the solar system would feel endless, a vast ocean of time and emptiness. From the sun to the edge of the Kuiper Belt, the realm of icy comets and Pluto, light needs nearly 6 hours to complete its voyage. 6 hours for a single photon to cross our home system. If you switched on a cosmic flashlight at the sun's surface, Pluto wouldn't see it until hours later. That's the scale of our neighborhood, so enormous that even light struggles to connect its distant shores. Here's where the story turns mind-bending. If the sun were to vanish right now, just blink out of existence, Earth wouldn't notice. Not immediately. For 8 full minutes, our planet would keep orbiting an invisible star. Jupiter would continue its motion for 45 minutes. Neptune wouldn't know for more than 4 hours that its parent star was gone. The speed of light defines not just motion, but the very rhythm of reality. Everything we see in the universe is history, an echo delayed by distance. Every time you look at the sun or gaze at the stars, you are staring into the past. The light entering your eyes began its journey minutes, years, or even millennia ago. Each photon is a tiny messenger, racing through the cosmic darkness to deliver a moment of ancient truth. So, the next time you step outside and feel sunlight on your face, remember this: That warmth began its journey 8 minutes ago, born in a nuclear storm millions of kilometers away. Because in the grand race of the universe, light always wins, but never instantly. If this cosmic journey blew your mind, hit like, subscribe, and drop a comment below. Which planet's sunlight delay surprised you the most? Until next time, keep looking up. The universe is still running its greatest race.